All right, in this video, we're going to look at the second skill that we learned from Pythagorean Theorem. This skill is how do we use the Pythagorean Theorem to find the leg of a triangle, the length of the leg. So again, like if Pythagorean Theorem is like a screwdriver, you can use it for multiple things, right? Like sometimes a tool can do more than one things that you need a tool to do. That doesn't make the tool wrong. That means that you have to be creative in your approach, and you have to think ahead of what tool am I using and why, and what would that kind of look like. So here we want to find a missing leg of a triangle. If you remember from the last skill that we talked about, Pythagorean theorems are used for right triangles that are of this format, where the vertical side, the side that goes up and down, is A, the side that goes left and right is B, and then the hypotenuse, the longest side, is C. Well, when I match this triangle up here, I actually find that 41 is in the C spot, 9 is in the A spot, and the piece that I don't know is B. And it's labeled X here, which means it's unknown. We don't know what it is. It could be any number, really. Of course, there are more numbers that are likely for it to be than others, but we want to figure out exactly which number that is. So that's why we use Pythagorean theorem. We have our A, B, and C value, and I'm going to go ahead and plug in what we do know into this theorem over here. So we agreed A is 9, so I get 9 to the power 2. B, we don't know. That's the missing piece that we are trying to find, so I'm going to leave that as B to the power 2 then. And then C we know is 41. Okay, and then just like in the last video, there are pieces here that I could put in my calculator. In my calculator, I can do 9 to the power 2, and I find out that that's equal to 81. And then I still have the B. That's raised to the power 2. And then 41 to the power 2, I can't do that in my head. I doubt that any one of you could do that in your head. It's a very big number, right? And, it's definitely okay when you're dealing with bigger numbers to put things into your calculator. I don't want you to feel bad about that. So 41 to the power 2, put that in my calculator. It's equal to 1,681. Okay, so we cleaned up our equation, and in the previous example, we just combined things together because they were next to each other, right? Like in the previous one, it'd be like 81 plus 1681. But that's no longer the case. They're on opposite sides of this equal sign here, right? This equal sign is like a divider. It splits the sides in two. So what should my first step be? How can I get these onto the same side? And if you want to get something over, you need to perform the opposite operation. Try to combine those words there. So 81 is being added to b squared. So what I'm going to do is I'm going to subtract 81, and that'll get rid of it. It's gone now. It's just, we forget about it. But it's like a balancing act. If I get rid of 81 on the left side of the equals, I also have to get rid of 81 on the right side of the equals. So the left side is going to then have just a b squared, which is exactly what we want. We want just b squared. And then this will be 1,600, or 1,600. Now again, I don't want b squared. It's helpful to know, but I just want b. If you think about this triangle, 941 and then 1,600, that doesn't make any sense. Especially since we know the hypotenuse is the longest side, this side right here. So 40 is the biggest it could be. So we will take the square root of both of these numbers. Square root of 1,600 and then the square root of b squared. What will that do to b squared? Well, it'll actually just turn it into b. And then the square root of 1,600 is, again, one of those things that you just have to put in your calculator. Because it's a big number, right? Doing that in your head is very, very difficult. And if you can do that in your head, you should be on game shows. This is pretty much what I suggest for you. And that would be 40. So I could kind of mentally check this too, right? If I go back to this triangle, this being 40, it's smaller than the hypotenuse, which is the longest side, and that's exactly what we wanted. So there's our skill. That's how we could use the Pythagorean theorem to solve for the missing leg of a triangle.